Hello, I'm Colin Perry. This is Andrew Ike, and we are going to explain the slope of a line, what it is, and how to find it.
The slope is the ratio of the change in y over the change in x. The slope of a line is the measurement of the inclination of the line.
Using slope algebraically, given 2 points, x1 and y1, and x2 and y2, you can find the difference in y coordinates or the difference in x coordinates. It can be found by using y2 minus y1 over x2 minus x1.
The slope is also the slant of the line. The slope on a line never changes, unlike a nonlinear graph, where the slope is constantly changing. You can easily find the slope on a linear graph by finding 2 points and measuring how far up or down and to the right or left to get from point A to point B.
The slope of a line can be used in 2 forms of a linear equation: slope-intercept form and point-slope form. Slope-intercept form uses y equals mx plus b, where n is the slope and b is y-intercept. Point-slope form uses one coordinate on a plane and uses y minus y1 equals m times x minus x1, where x1 and y1 are the 1 point and m is still slope.
You cannot find the slope of a nonlinear equation like the equation for a parabola. Since a parabola isn't linear, it doesn't have one slope that goes across the line.
Hello, my name is Colin Perry, and I'm going to explain the slope of a line. First, slope is the ratio of the change in the y coordinates over the change in the x coordinates on a line. The slope of a line is the measurement of the inclination of the line. That means that the slope on a line never changes, unlike a nonlinear graph where the slope is constantly changing. I've created a simple graph here of a line, and we're going to find slope. You can easily find slope on a linear graph by finding 2 points and measuring how far up or down and to the right or left to get from point A to point B. This method is also known as radical run because you place how far up or down you went above how far right or left you went in the ratio. Now, our 2 points here are 0, 0, and 2, 2. We're going to find the slope easily by going 2 up, then 2 to the right. That makes our slope 2 over 2, or 1. Now, the formula I used for this is called slope-intercept form. This is one of the 2 linear equations that we'll be using today. This is the line I made. It is following this format where m equals the slope, c was 1, then b equals the y-intercept for 0, where it intercepts right there. This other form is known as point-slope form. This uses slope like it did in slope-intercept, but instead of using intercept, it uses a random point along the line, as you can see here by x1 and y1. If I change, I'm going to make another line using this point-slope form. Let's say y minus 2 equals 3.
And this is sped up 1.5 times.
X minus 1. There. As you can see, 1, 1, 2 is a point on our line. But our slope is still 3 because we go from 0 to -2 up to 2 and then 1 over. That brings us 1, 2. That makes our slope 3. Now, if I change the slope of these lines, it will either become more gradual or steeper. So let's change this to 3. As you can see, changing up makes it steeper. Now, if I go back and make it 0.5, it will be more gradual. Let's go ahead and change that back to 1. The same goes for down here. Changing the slope will make it either steeper or more gradual. Now, if we go back up to this slope-intercept form and we try to change the y-intercept, that will move the line up or down. Using negatives in point-slope form or slope-intercept form will have an opposite effect if you use positive numbers. As you can see, if I change this back to 0, but I change this to a -1, that makes the slope go the opposite direction. The same goes for point-slope form. If I make this a -3, it will go the opposite direction. And if I change these negative signs inside the parentheses to pluses, that will move the whole line. And if I make a nonlinear graph right here, the parabola. Let's do y equals 2x squared plus 4x plus 1. That makes a parabola. Now you cannot find the slope of this. As you see, our lines here were a constant slope the whole time. On a parabola, it is not constant, it is constantly changing. That makes it impossible to find the slope of a parabola.
All right.